All right. So we're going to work a practice problem together to learn how to find the atomic mass of a given element once we have some information about the masses of its isotopes. So this problem says a certain element has two naturally occurring isotopes. Find the atomic mass given the following data and identify the element. So mystery element X has two isotopes, X35 and X37. We have the mass for each isotope. As you can see, the mass isn't the rounded off version. So even though it's X35, the actual more precise number for that mass is 34.969 AMU. We have those masses. And then we have percent abundance. Percent abundance basically means if you were to look at every single atom in existence of this element, what percentage of those atoms would have this mass, would be this isotope. So about 75% of all the atoms of element X are X35 atoms, and about 25% are X37 atoms. So it's much more likely that if you were to pull a random atom of X, element X, that it would have a mass of 35 than it would have a mass of 37. So we have a special formula to help us do the math on that takes into account the fact that there's so many more atoms of X35 than X37. When we do this math, the first thing we're going to do is start to plug in our numbers. So first, we plug in our first mass number. That was supposed to be a star, but was definitely a fail. So we plug in our first mass number here. And then we need to multiply it by the percent abundance for that isotope. Now, we have to convert from a percentage to a decimal, just like we practiced earlier. I'm going to use the move the decimal point trick. And we go from 75.53% to 0.7553. Then we're going to plug in the values for our second mass. So this mass here, again, we're going to move the decimal point over. So we have 36.966 AMU multiplied by 0.2447. Then, remember our PEMDAS, right? We have to first do multiplication before we can do addition. So we're going to multiply 34.969 times 0.7553, and that gets us this number here, 26.4121 AMU. Remember that we're not going to round any of these numbers until the very end. We're going to do the same thing for our second set of numbers to get 9.0456 AMU. And then finally, we're going to add those two numbers together to get 35.4577 AMU. And then we can round to the hundredths place. So looking over at that 7, we are closer to a 6 than to a 5. So 35.46 AMU is our final value for the atomic mass. 35.46 AMU. Now, to identify the element, we need one more tool, and that's our periodic table. Normally, we would be looking for the atomic number, but in this case, we found the exact calculation for our atomic mass. So we're going to use that instead to figure out what our mystery element X is. So let's start looking for an atomic mass of 35.45. Here we have approximately 7, 9, 10, 12. Keep looking. Aluminum, we're at about 27, 28, 31, 32, and we find that chlorine has an atomic mass of 35.45. They left an extra decimal on, that's fine, 3. So chlorine is our mystery element. Whoops. So our correct answer for that second part is chlorine, which